Good morning, sir.
Good morning, Sanjeev. How are you?
Fine, sir, fine. Welcome to this presentation, sir.
Okay.
Am I audible, sir?
Yes, you are audible.
Okay, sir. Okay. So let's wait for 2 minutes for the other participants to join, then we'll start, sir.
Okay, no problem. I'm audible?
Yes, sir. Yes, sir.
Okay.
Indoria ji, good morning.
Good morning, sir. Good morning.
So should we start, sir?
Yes, we can start.
Okay, sir. Okay. Okay. So this is the last lecture in our series of lectures, which we have organized using this ATAL platform. And for this, I welcome Dr. L.M.Saini. He's a mentor and supervisor. He's my supervisor as well. He is a distinguished academician and researcher with over 3.5 decades of teaching and research experience at the NIT Kurukhetra, where he has been serving since 1988. He has also served as the head of the Department of Electrical Engineering from June 2019 to May 2021. And he holds BE in Electrical Engineering and MTech in Electronics and Communication and Control Engineering and a PhD. His areas of expertise comprise analog and digital electronics, power electronics, embedded systems, power systems, and intelligent control. Dr. Saini's outstanding research contributions have earned him consistent recognition among the world's top 2% scientists and Elsewhere's Stanford University Global Ranking for multiple consecutive years from 2020 to 2025. He was also featured in Scholar GPS 2024 Global List, ranking within the top 0.5% worldwide in fields such as forecasting, artificial neural networks, and intelligent control. He has published extensively in high-impact international journals such as IEEE Transactions on Power Systems, IET Generation, Transmission and Distribution, Renewable and Sustainable Energy Reviews, Electric Power System Research, and Energy. His research spans vital domains including load and price forecasting, smart grids, renewable energy integration, and multi-level inverter design. He holds several Indian patents, including innovations in electricity theft prevention, automatic liquid control systems, and portable artificial breathing systems. Among his honors are the Best Faculty Award 2017 from NIT Kurukhetra and the Highly Commended Research Award 2009 from Emerald Literary Network. Through his leadership as head of the department, his research experience, and his mentorship, Dr. Saini continues to inspire students and researchers in advancing the frontiers of intelligent energy systems and automation and control. So I welcome him for this presentation. So I request him to start his presentation.
Thank you, Sanjeev, for introducing me. I hope most of the participants must be PhD scholars or postgraduate researchers or undergraduate students. Just I want to get some idea about the audience before starting.
Yes, sir. Yes, sir. Mostly are from faculty members or research scholars from different institutes.
Okay, very good. Thank you. Because the ground reality must be known before doing anything. So I'll be sharing my experience of forecasting and how we have done over the years, and that can give insights to the young researchers, the budding researchers, and moreover, one more thing, of course, this forecasting will keep on going on. I would like to share one more thing that your research should help the common man. Because you may be a very big researcher, you may be a top academician, what is your advantage to the common person on the street? So you must be emphatic to that common man, and you must do something for the society. That is what is required. So always think when you are doing research that your research should not be buried in the books in the as a part of the library. It should be delivered in some format to the common person. In India, we are having many problems in the country. Floods are there. You have seen in just in the past, they have created havoc in Punjab also, in Himachal, Uttarakhand, Sikkim, and many other states. So, whatever research we may do, of course, we won't be doing concern to the floods, but I'm just giving you an idea that our research should help the common man on the street. So one of the problem which I tried to solve in the past was that this electricity power theft through a patent, of course, and some other tasks were also taken up. For example, we developed a technology for the railways for the prevention of rail accidents, and but it is not necessary that the society may accept your technology. It may not happen. That is also possible. But that should not thwart you from doing anything. You should keep on working to help the society because it is your duty as a technologist. So it is your I can say a part of your karam that you must do something for the society. You must give back something to society. You may be using some taxpayer money, so you should think in terms of giving back something. Okay. So in this context, I started the problem of solving the forecasting because there were frequent power cuts. So when we used to ask our friends in the electricity department, they said that we were not aware about this, that this much load will come, and sometimes there were burning away of the transformers, distribution transformers. Now a distribution transformer costs in crores of rupees. So the patent which I am having was not only covering the prevention of power theft, it was also taking care of that no distribution transformer may get burnt away. Because what happens that when people will steal electricity, they will not limit it to some extent. मतलब जितनी आ जाए उतनी ही कम है. वो फ्रिज भी चलाएगा, एसी भी चलाएगा, सब कुछ चलाएगा. तो उससे क्या होता है, ट्रांसफार्मर पे लोड बढ़ता जा रहा है. ट्रांसफार्मर इज नॉट डिजाइन फॉर द पर्पस. आपने कनेक्शन लिया है मान लो 10 एम्पियर का, ठीक है, and you pay some amount to the electricity person, lineman, and get a meter installed of a larger current rating, or you bypass your energy meter and you withdraw a current which is not supposed to be handled by the distribution transformer. तो क्या होगा, वो ट्रांसफर फूकेगा. So this is a big problem in the society, and that is why we solved it by a technology in which you were able to communicate over the power lines. So with the efficiency of, or you can say error of lesser than 1-2% only. Whereas ST Microelectronics, who were making power line communication modules, they have we tested their modules. It was giving 50% error. So that was so they then get interested in our technology. So this happens sometimes that, but you must think of giving something back to the society. So when I started forecasting, I thought to take data. Now data taking is a big challenge, because if you don't have a good quality data, then your forecast will also be not good. So when I tried to look around around Kurukhetra, so I tried to collect data. So data was, I saw that it was being entered manually by the person who was in charge in the substation, and that man may write sometimes, that man may not write sometimes the data, because and they will after a few days they will fill all the readings. So data is not reliable most of the times. So not only that, I also saw that you have a feeder. It was coming from one particular distribution transformer, and after restructuring, the same feeder was cut from that transformer and placed on a different transformer, from A to B transformer. So that means the data which was concerned to transformer A, that will in forecasting the same data is coming by the change of the load. So that will the technique will not understand what is actually happening physically there on the ground. So ground reality is mostly different from the theoretical or research you can say scenario. So then I went to Kalka, the one end of the Haryana, and I thought that there was one transformer which was feeding the entire load in that area, which after that Himachal was coming. So I thought these feeders will not be cut to and put to some different transformer, because there was a different state after that. So I tried to took the data, and when I went there to data, once I reached there in the late evening, the persons who were in charge, they were all just putting readings, and nobody was serious about the readings. They were just completing I saw them just completing the documents. भी इतना ही होगा जी data. But that gave me a very big setback. What I am trying to do, I am trying to help these people and to get some forecasting idea that tomorrow this much will be load or whatever it is. It's okay. But the data is totally fictitious. then ultimately I thought that I have to, instead of going at the tail end, I should go uh, towards the center. That is on a higher kV substation. So I went to 220 kV substation in Karnal. There I got some authentic data because people were serious. If you go to higher substations, people are employed there are somewhat more serious. They because they have some uh, issue in the they have some responsibility. They consider it a little bit. So there, from there, I took the data, and with that data, I forecasted peak load. So this started in around the year 2000, around 25 years back. So I will just introduce and I will show you what I did with that data. Okay, and how what was the recognition which I received. But a recognition is later on. And the main thing is that you are serving your own society. Otherwise, I could have picked up some data from some foreign site and we could have done very good forecast. But then satisfaction doesn't come from inside. That we are serving the persons who have no interest in us. But if we serve our own society, then one feels get motivated. So that is a thing which is also uh, sometimes helpful in doing a good research. So that was my point. I hope if anybody is having any question, you keep on asking. You can raise your hand or you can stop me anywhere. No issues. Okay. Okay. So my screen is visible.
Yes, sir. It's visible.
Okay. Okay. Thank you. So uh, let me see if we can get rid of this window. Okay. Got. Okay. So I'm just introducing forecasting. So forecasting nowadays, previously we were forecasting the actual power or load or like that. Nowadays, things have changed over the decades. The people are interested in clean energy, so they want to see that how much power I can get from the solar, how can power I can get from the wind. Similarly, the areas which are near the coastal areas, they even generate electricity from the sea waves. A good number of generators are also there. So, but this forecasting uh, can be from financial point of view because where money is important, you may not have to purchase electricity from the spot market. So in that case, even you have to forecast in 10 minutes ahead, 5 minutes ahead, or even maybe 1 hour ahead. But if you are going to bid for electricity price or like that, then that may be one day ahead, depending upon the electricity market you are taking care. And yes, any question? Okay, if no question. So we are having here different type of forecasting, and that is from because it is finance has come into picture nowadays. Previously, we used to forecast the load. The reason was that forecasting markets were sorry, electricity markets were not in prominence in the past. I'm talking about the year 2000. And at that time, electricity markets were not in India. Of course, it was not there, but in foreign countries also, very not much markets were there at that time. Later on, electricity markets they gain quite a prominence in their fields, and we have to worry about the bidding, etc. And but we forecasted load, peak load. So the question was that if you are forecasting, then how much error can be allowed in the system? So what was thought that if there is a 10, if you have predicted a load and there is an error of 10%, the system can withstand 10% error. Or in other words, if your forecast error is lesser than 10%, that means that it can be taken. Of course, accuracy should be high as possible. There is no issue in that. But sometimes you will find research papers, they are, if somebody has predicted an error of, let us say, 5%, otherwise will say mine is 4.99%. So that doesn't make a big difference until unless there is an appreciable change in the error. Okay. Moreover, what happens is that people forecast. We have seen research papers published in very good journals who have predicted for 1 week or only 1 day in a whole year. Just see that efficacy of a model can be established only if the model is good for at least over the year and at least for few years. Then you can say that your model is good. Otherwise, if you are forecasting for 1 day or for 1 week, it doesn't make any sense. So, of course, forecasting helps in grid stability. For example, if you put more load on the grid, then it may lose synchronization and it may go in unbalanced state. So that should not happen. And particularly when you in the corporation of renewable energy, the moment the cloud comes, immediately you will find a ramp, the power going down, coming from solar. So how to arrest that downfall of the power is also a big challenge. You have to either immediately start your generators, or if you have some stored energy at some place, you can compensate. So because people will want power, you can't cut power to, isn't it? So if you are having immediately clouds coming up and resulting into immediately decrease in the solar power, you have to similarly for wind. All these energy sources, renewable energy sources, are very erratic in nature. So that brings a new challenge into the market. So fluctuations in renewable generation. Okay, so we have to anticipate the fluctuations in renewable generation. We have to arrest those fluctuations by some proper methods, and we should have energy sources of the equal rating which we are otherwise generating from the renewable operations. Okay, so that means we need to have some reserve allocation. Okay, and otherwise it will make the grid unstable. Clear? And so we may have to go for unit commitment. We may have to turn on some generators, and we have to also worry about economic dispatch. We should not be overloading some feeders that it may result into problem creation, or they may not become bottlenecks. And optimal power flow should be there over the feeders. So all these things can be handled in a very proper manner if you if you do the forecasting well. That is, you know that this much amount of power you have to supply. So you have to accordingly establish the route to those. Uh, any question, please? Okay. Uh, okay. So these are. So we have to sometimes take readings uh, from the power system. So those units which will be taking the readings, they are known as remote terminal units. They can be installed in substations, because in substations you have the power equipment, and you can assume that the units which you have installed in the substations, because all feeders are going from the substations. Okay, so it is easy to install your telemetry systems in substations, because the whole feeder will be having the same, the power will be transferring from the substation to the users. Okay, and then this readings have to be communicated. So nowadays you have internet, very fast internet available. Otherwise, previously we used to transmit over power lines, and that was also a big challenge, to communicate over power lines. And so uh, once the data has been communicated to the central station, then the state estimator or the controller there can estimate what will be the next state of the power system, and whether it is not getting any, it is not worrisome. So that we need to take care of it. Okay, and we have to take care that there is no penalty on us, that we are otherwise, if you do not supply power to, or if you have committed that this much power you will supply, give to the utility, and but you are not able to provide that much amount of power to the utility, so that will also you may have to pay a penalty for that. Okay, so these are all remote terminal units. They cannot be installed in the field, mostly because the problem of communication. You need to install the communication equipment also in the field. So, and the field is prone to weather conditions, whereas in substation you have a controlled weather conditions. So, just see all these equipment of remote RTUs. They are all electronic equipment which are measuring your how much power flow is occurring, and it is difficult to install them in the field for the reason being that particularly during foggy seasons, your electronic circuits, they get spoiled very frequently, and so either they should be protected by proper housing of some good quality materials. Otherwise, the best place to install those units is at the start of the feeder. Okay, and okay, this information of forecast is helpful in economic dispatch, automatic gain control, optimum power flow. So all, and you are also incorporating renewable energy. Previously, people were not so much serious about renewable energy. Now they are saying that at least 30%, 40% penetration should be there. So there's a demand because of the if you are generating power through burning fossil fuels. Okay, so there are some forums, among which India is also a part of, or a part of those treaties, that our carbon emissions won't be more than this value. Particularly if you see the carbon emission of India, it is much lesser in comparison to many advanced countries or developed countries, and because mainly there are two reasons. that our energy consumption per capita is very less, whereas the energy consumption our country is very good, is geometrically, or you can say placed in the globe at such a place that we have very good sun. And but if you see the cold countries, they need heating for their houses, which is a big amount of load. And because mostly they have cold months rather hot months. So also the energy requirements, they we most of us Indians, if you see the majority, rather, I like to say, they are traveling in the trains, which can be fed from power being generated through uh, solar or renewable sources. Okay. Whereas if you see the transportation system in developed countries, most of them they prefer to fly. And when you are flying, you can't take power. Now, of course, there are news that you have some. It is, of course, they have the technology is coming up for electric planes also coming up, but otherwise, most of them are based on the fossil fuels, and that is based on the oil, and they are also resulting into a huge amount of carbon emission. And that way our country is better. Our heating requirements are not there so much in comparison to the West, and our majority of the people they prefer to move on trains, and which are electricity driven, and therefore those that electricity can also come from the renewable sources. We need only to increase the penetration of our renewable sources. We only need a better integration of our renewable sources with the grid. Fortunately, we are having nowadays net meters. That is, you can sell electricity to the utility, and you can buy as well as you can sell. So you can have your rooftop solar plants, and uh, of course, we in India, this rooftop solar plants are not very prominent. Particularly in Haryana, we are having it here. The Huda, that is the Haryana Urban Development Authority, they have put mandatory that if you have a plot of size more than 1 canal, then you must install solar plant at your rooftop. So that is a condition by the mandatory condition by the Urban Development Authority. But however, it doesn't stops people having lesser area than 1 canal to also put solar rooftop. Okay, so we have a good amount of subsidy also on these type of solar plants, and we can sell electricity also. So I think most of us should prefer of having solar power plants in our rooftops, and that will and also on the buildings, all the institutions, maybe government or private, they should also put solar plants on their rooftops and generate most of the power to become Atmanirbhar. So that is what we have. It is a better way of. That is the advantage of studying all this. Okay, so this is a particular type of. If you have what type of forecasts are required? So 1 to 48 hours forecast is good for unit commitment. 5 minutes to 1 hour forecast. I told you spot markets. So that is for economic dispatch. You want to supply electricity at minimum, okay, rate, then seconds to minutes, like that, and minutes to days for market operations, because most of the electricity markets are 1 day ahead. So the window opens the previous day, that is 24 hours before, and you have to commit electricity, that this much electricity you can supply as a resource provider of power, and at this particular rate, and that bidding is done by the different players. And then you have real time market also, which is of course very erratic in nature in comparison to day ahead market. So it is always good to go for day ahead market rather than the real time market. So we have here different types of forecasting. Solar forecasting is there, wind forecasting is there, load forecasting is there, and price forecasting is also there. So these are the all types of forecasting which we are doing in power system field. So in solar forecasting, we are forecasting solar irradiance, and or we also sometimes forecast. This can be taken as input also. That is based on the past radiance. We predict the new radiance, what will be there, how much, and what will be temperature, or what is the present temperature, and what will be the next temperature after half an hour ahead, or like that, or maybe day ahead, like that. It's okay. So then how much cloud cover will be there? So all these are weather parameters, and they can be also acting as input to the forecasting. And we are forecasting the amount of PV generation which is possible using solar forecasting. In wind forecasting, we are predicting what will the wind turbine power output. Okay. So, and the input variables are wind speed, the direction of wind speed, the pressure, because if the pressure changes, then there is a wind speed increases. So these are sometimes correlated also. Pressure and the wind speed are sometimes correlated also. And then the humidity, that can also be taken as input variable. So you may have sometimes n number of input variables. Sometimes the data is available to you, and uh, so you have to see how it is correlated with the power. That is your output. Okay, and there may be some autocorrelation also between the input variables. So those variables which are having very good uh, very good correlation with the other parameters or other input variables, they can, some of them can be neglected. So that will reduce your input matrix for forecasting, and therefore your forecasting will become faster. Okay. So, but your correlation between those input variables should be more than zero point 0.9. So, in that case, you can reject one of, you can drop one of them. Okay. So, that can be done. Then, of course, the price forecasting helps to achieve the objective of electricity market price forecasting, and the input variables are demand, the generation mix, that how much amount of solar power is coming, how much amount of wind power is coming, how much amount of fuel power is coming. That is going to decide the price, because you have the inputs also. If you are burning fuel, there is a you are spending on it. Okay, so your price will be higher in that case. And now another user, another power provider who is only based upon solar or wind, he doesn't have to pay to the sun or to the wind. So he may be quoting very less amount of price for the power. But his power may be erratic in nature. If wind goes, speed goes down, or the cloud comes up. So, so there are other type of challenges for that type of um, provider, so power provider. Okay. Any questions if you have, I can take up. Otherwise, I will go ahead.
No, sir.
Okay. Thank you. So we can integration of renewables into the grid. This was what I was talking about. So this is another area of research. Some of my research scholars, they are also working on this. So we try to connect the solar power or wind power to the grid. So when we integrate, we have to see that synchronization of the voltages, three-phase voltages. Okay, that has to be there. Number one. Number two, there should be very less leakage current. No current should go to the ground. We are able to transmit all the power to the grid. Okay, so for that sometimes also we required um, very good topology of the power electronic equipment. So power electronics is going to help integration of the renewables with the grid. So of course, if there is any fluctuation in the power, solar power, for example, cloud has come. Okay, so you won't be transmitting power to the grid. So in that case, how your interface circuit will behave, whether there will be any problem in that connection. So that also you need to worry about. Okay, and you will like to minimize the uncertainty and the volatility in the power transmission curve. So that you need to worry about. So they are the challenges for your forecasting. So you have to make some decisions for operators, for traders, because traders are only interested in money making, and operators are interested in that things go very well. Okay, they have nothing to do much with money, and the policy makers that whether it is possible or how much, what type of plant you are going to connect to the grid. So those decisions have to be made by different type of persons which are there in the market. So the grid operators, they have to worry about the how much, whether the generation which is coming, at what price it is coming. Okay, whether he is having in a reserve management, supposingly the cloud cover comes, so the power will go down. So does the person is having any reserve? Like that, sometimes when we are giving a new uh, tender to a vendor to do something in the institution or at any place, we look कि इसने पहले कितने ऐसे टेंडर किए हैं. So in the same fashion, we look how much reserve management this vendor is having. Supposingly, it should be at least 75% or 50% of his commitment. कि अगर वो कह रहा है कि मैं 50 किलोवाट या 50 मेगावाट दे रहा हूँ आपको पावर, तो उसके पास रिजर्व कितना है. So that is the thing which matters. So trader is always interested in his main purpose is to plan the bids and to manage the risk involved in that and maximize the profits. And policymakers is for forecasting of long-term planning and renewable energy targets. So their job is mainly, so different persons are there in the organizations of such companies which are doing this business, and they have a different purpose. So and the targets are simple, that renewable should be integrated with the grid. So the aim is that much. But in that, people are also interested to make money out of it. People are also interested to reduce the carbon emission of the country. And so different objectives get met by the same work. The concept is that. Okay, so you have environment benefits. That is, you are providing clean energy, or you are lowering the carbon emissions. Okay, so and you are, instead of 30%, you're going for 40%, 50%. So you are having gigawatt hour power generation in the country. So a 30% or 50% also in gigawatts. So you can, or terabytes, like that. Okay, so obviously It is not a small power. But if every organization in the country, every department in the institution, they take the responsibility that I am consuming, for example, 1 megawatt. My building is consuming 1 megawatt power. Okay, then I should generate at least zero point 0.5 megawatt. That we should have targets for that. Otherwise, people will uh, that will of course make your environment friendly, your global warming. Okay, all these things get automatically uh, taken care if everybody takes the responsibility. So, as a countryman, everybody should be always think how whether I'm having my house or I'm having my department. So because just see, we are not using the rooftops of our departments for the, and I'm not sure about Thapar, but we are having here a 1 megawatt power plant in our NIT Kurukhetra. So, Sanjeev, can you share what is the situation there? Is your institution also having some megawatt power solar power plant in your institution? I think Sanjeev, I am audible.
Audible?
Yes, sir, audible.
Okay, okay. Any idea about your institution? How much megawatt plant you have installed? Or you're planning to install?
Hello.
Yeah.
Yes,
Sir,
sir.
please repeat, sir.
My question is that is Thapar Institute is having some solar plant in the institution? A solar plant?
No, sir. Right now we don't have any solar plant at Thapar, and we have a dedicated supply from PSPCL. It's 66 kV line.
Okay. So that is what I think the need of the day. That
But when new hostels are coming up, where I think solars will be installed.
okay, that's good. But you are having rooftops. There are many buildings in the Thapar Institute. Am I right? So,
Right now we don't have any, but in
but you can plan. You can plan to have a solar power plant
okay,
in
sir.
your institute.
Okay.
And right now in the NIT Kurukhetra, we are having 1 megawatt
1 megawatt solar.
solar power plant. Yes.
Okay, sir.
All the rooftops of the NIT, they are covered with solar panels.
Okay, sir.
This is, I
Although in
think,
Punjab, for in Puda buildings, it is compulsory that you must have a solar
हाँ
plant if you want to
हाँ वो तो मैंने
have a
बताया है,
electricity connection.
एक कनाल से ऊपर को तो मैंडेटरी है.
Yeah.
हाँ, but lesser than that, it's optional. But to become self-sufficient in power, we must uh, uh, think of installing solar power plants, whether the institution is there or at the house level, whichever premises we may be living in, we must install solar plants at our rooftops. Why to waste energy, isn't it? And moreover, it also
Yes.
gives you one more
Yes,
benefit.
sir.
Okay, I will just take up one question. Before that, I would like to complete my statement. Just see that when you are installing solar power plant on the rooftop, the top you can say the layer of the building, it will not get heated up because you have panels on
Yes,
the
sir.
rooftop. So the panels will cover most of the uh, roof of the building. So you
Sir,
don't
yes, sir.
require much air conditioners. Otherwise, the top layer of the building that will get heated up too much. during summer season. So it is a two-way advantage. You are generating electricity to feed the air conditioners, which are heavy in requirement at the time of summer, and so that is one advantage. You are okay. So you are not depending upon the PSPCL, and also you are having your bill will it is economically better, isn't it? But you have to invest once. Not only that, even if you don't have money to invest, because investment is a CAPSA model, capital uh, like that. You have to invest in capital. Okay, then your electricity is yours. But there is another model. I'm forgetting its name. In that, you can uh, ask some of the vendors to install the solar panels at, at their cost, and they will sell you the electricity at some rate, uh, like that. So that rate is normally very lower than the rate at which you are getting from the utility. So that is the advantage, because the vendor will also take, if he is investing his own capital in your solar power plant, he is utilizing your rooftops, but he will be selling you power at a very meager rate in comparison to the rate at which you are getting it from the utility. So two models are there. So you can, as per the amount of resources available in your institution, you can go for any type of model. So we are having here the solar power plant, I think, for more than 6-7 years back. We installed this 1 megawatt power plant. 6-7 years, more than, I think, maybe more, around 6-7 years on an average, I can remember. Okay, so Thapar can also think about this and install a solar power plant. So we have to be take initiative for this. Yes, any question? Somebody was asking some question.
Any
Anybody?
question from the participant? No, sir.
Okay. So different techniques which are used for forecasting are either based on statistical techniques, and then you have machine learning methods. Now, in this, I would like to add one more thing here, that mostly nowadays students they will adopt some machine learning methods, this technique, that technique. Okay, but they will not invest their energy in knowing that whether the statistical method has failed in giving a good forecast. They directly employ a very heavy technique, a computational intensive technique, maybe like many techniques are available. People are running after artificial intelligence, AI. The AI technique, you have to. I have employed AI technique, but we should ensure that just see, we first tried through uh, the normal methods. Okay, the mathematical methods, whatever are available. We should start from the ab initio. Okay, for this data, I tried and I got this much error, correct? And but I was not satisfied with it. I was still want to improve the error. Now, this satisfaction that whether your models are sufficiently accurate or not, I told you that if your system, how much your system can withstand. For example, in peak load, I told you that it was, if it is error is, if the system can withstand 10% overloading. Clear? So that means an error of 10% can be a point of satisfaction. But of course, the better the forecast is. Some says, oh, my forecast is 0.0015%. Okay. Oh, very good. You have done a very good job. It's okay. But whether it is required, that is the question. Of course, if it is concerned to the money involved, then everything is okay. Because when you go for trading, every penny matters. Okay. But otherwise, for this, so far as this system is concerned, so far as the electrical parameters are concerned, so that the system may not go into unbalance. Okay. That is our first point of worrisome. That we should be worried about this point first. Money comes later on. Okay. You may uh, earn money or you may not earn money, but at least your system should not fail. Okay. So if you first you and so you should first try the mathematical existing mathematical models. If they are working very well, there is no need to go for AI methods. But if they are not good enough, then of course there is a need to go for the AI methods, and then that will automatically prove that your machine learning methods are good, because normally AI methods do not tell the model. They only tell, okay, you have used neural network, for example, okay, but they will not tell you the equation, how you got this. And whereas if you have a mathematical model, you get a proper equation for that. Okay. So you can, that is the advantage of statistical methods over the AI methods. But mostly it has been seen that AI methods give higher accuracy. Okay. Uh, because there is a non-linearity, if they are usually all models, until and unless they are complex models, non-linear models, uh, because most of the systems, it is just like an interface. You must have studied a maximum power transfer theorem. I am just taking you to the roots of the electrical engineering. That if you have same amount of load resistance as the source resistance, your power transmission to the load will be maximum. In the same fashion, your error will be minimum if your method which you have employed and the system on which you are applying, they are also having the same complexity. Okay. If that is the case, then it means that your method is good. So sometimes there are some statistical parameters like kurtosis, skewness, which can help you in isolating a particular method for a particular type of data. It is not that you are applying every method to every type of data. No, don't do that type of thing. So prefer applying methods intelligently. Okay. So that is what I would like to say to the young researchers. So different AI methods are there nowadays. Deep learning and many more such type of methods have come, which can capture temporal and spatial dependencies. Okay, so you have LSTM, GRU, CNN, many methods are there. I will just discuss some of them. Okay, so these are just different types of forecasting models. You have physical models, statistical models, or AI models, and then hybrid models. That is uh, some part is you can say ensemble type. That is, you have more than one type of model. Just like you are having vehicles which are based on fossil fuels, you have pure electric vehicles, and you have hybrid models also, vehicles also. Okay. In the same fashion, you have different type of forecasting models. Okay. These are the different advantages and disadvantages of different type of models. Okay. And I think with this I have already discussed today. So ultra short term forecasting is just a few seconds to 1 hour ahead. Short term is 1 hour to 1 day ahead. Medium term is 1 day to 1 week ahead. And long term is 1 week to 1 year ahead. So And but at the same time, I would like to add here that you must forecast to prove the efficacy of your model. You must forecast over the years. Only then you can say that my model is good or it is having this much error. Now the error, different metrics are there to measure the error of any model. Mean absolute error. Okay. So error can be plus, error can be minus, but error is error. So that is why we take absolute of that error. Whether on this side of the curve or on that side of the curve, we try to reduce that error. But if we are employing a mean absolute error, then that means that we are just it is a linear variable. Okay, so sometimes we want to penalize the errors which are far away from the curve, or the points which are far away from the curve, or residuals which are far away from the curve. Okay, so in that case we have to go for the root mean square error or squared error or mean square error. Okay, but sometimes what happens that, for example, your let us say load is 1 watt. Okay, I'm just taking an example, and you are having an error of 1 watt, that is 100% error. Okay, so but if you are having a load of 1000 watts and you have an error of 1 watt, so that 1 watt, or let us say you are having a load of 100 watts and you are having a 1 watt error, so that is a 1%. So just see that 1 watt error, if your load is of 1 watt, is 100%. And the same 1 watt error, if your load is 100 watt, is 1% error. So 100%, 1% makes a big difference. Okay, so that is why you have mean absolute percentage error. Okay, but you have to take care that it should not be divided by 0, otherwise it can create problem for you. Okay, so there is another accuracy of the determination, that is how much your prediction curve is closer to the actual curve. So for that we have coefficient of determination, that is R square. This is statistical measure. Okay, there are expressions of these. I hope you can pick up any statistical books, you can get in that. Okay, so you can see different types of load curves are there. Okay, and or some are load, some are price. Okay, and we have different type of complexity in them. Yes. Hello. Hello.
Mr. Rama.
ସବୁ ସମ୍ବାର ପାଇଁ ଚାଲିଛି ନା, ସେ ସବୁ ଇଏ କରୁଛନ୍ତି।
Mr. Rama, is there any question?
आवाज आ रही है? हेलो।
हाँ सर, आ रही है। Mr. Rama, is there any question? Okay, go ahead.
Hello.
Sir, it was, I think it was by mistake.
Okay, okay. No problem. So this is the range of the errors which are there in different type of forecasting. So for load forecasting, the error should be lesser than 10%. That is what I told you. And MAPE is, of course, we have been able to achieve 5 to 10%. Okay. In price forecasting, because price curve is very erratic. Sometimes hedging is also there. People play games in that. So because they want to make money out of it. Okay. So their error is not only due to the natural reasons. Hello. Okay. So there the error is more in comparison to load forecasting. So I think somebody wants to ask some question.
So if somebody wants to ask some question, then please put it in chat box, because we are not able to listen what he wants to.
म्यूट ऑल कर दूंगे मैं एक बार.
Okay. If no question. So we have a more error in case of price forecasting in comparison to load forecasting. And solar forecasting, the error is more than 10%. The reason is that due to cloud cover, clouds frequently coming. Okay, sometimes you are not sure when they may come. And wind forecasting again, due to change in the wind pressure, there is a change in the wind speed, and hence there is a change in the forecasting also. So forecasting accuracy is of the order of 20 to 30% in that case. So this is just giving you a rough idea of what is there. Okay. So okay, I will just like to share some of my research papers. Otherwise, I hope this whole knowledge is available to most of you. Okay, I have shared.
So please share your PPT at the end of the presentation, after the presentation, so that we can upload it on the AICTE website.
Okay. Is my research paper PDF visible to all of you or not? I think.
So please share your screen.
Okay. I will again share it.
And we have time till 11:45. And
Okay. I will try to finish before that.
Okay.
Okay. So this was the first research paper which I published in IEEE Transactions in Power System out of my PhD. I employed artificial neural network based peak load forecasting using conjugate gradient methods. So I employed some, I think, 4 to 5 techniques in this research paper. I showed, here. So first I took the simple back propagation, and then I took up 4 type of conjugate gradient methods. And you can see here the accuracy which I am getting is of the order of standard back propagation method. It is for 1 week ahead. For week ahead, I am getting 2.78, and it is better using scaled conjugate gradient 2.4. Okay. Then Fletcher-Reeves conjugate gradient 2.43, and Powell it is 2.32, and Powell-Belay it was 2.31. So out of all these, you will find this Powell Belay conjugate gradient was gave minimum error, weak ahead error. Okay, so in all the four seasons, so we have done it in different seasons of the year, because I told you in the starting that people will do it for one particular week of a particular season, and they have published research paper. Sometimes that pinches us, that is not a, that cannot prove that your model is good until unless your model withstands all the four seasons, and if possible over the years. So, so this paper was published in 2002 in IEEE Transactions on Power System, and okay, so different type of days like working day, holiday, Saturday, Sunday, they were also taken into consideration in this, and different variables were taken, 21 variables, 11 weather parameters and 21 variables were incorporated for this. This is using the data of Karnal, which I told you, 220 kV substation. Okay. So that gave me the motivation also that I am working for my own countrymen. Okay. But due to the problem, sometimes due to data not being accurate, you may get larger errors in that case. So then you have no choice except to shift to the uh, data from the advanced countries. Okay. So I have also thanked Haryana Vidut Prasar Nigam Limited for providing me the peak load data, and I took the weather variables from Central Soil Salinity Research Institute, again located in Karnal, nearby, for providing the weather data. So we have thanked them also in my research paper, because you must. So that is the concept is that if you have taken data from any uh, place, then you must thank them also. Uh, it is not like that that you just take the data. Another research paper which I published uh, on the same data was using Bayesian regulation, resilient and adaptive backpropagation. So I employed, I think, around three methods uh, for this. You can see here. So yes, standard backpropagation. Then three more methods were used here. Okay, and the error was again of the order of 2.5%, week ahead error. Okay. Now in this, I just changed the technique. I used 28 variables as input variables. Okay. Though this data has been taken from the Soil Salinity Research Institute. And then I also checked the correlation with the output variable. Okay. So the variables which were giving very good correlation, particular more than 0.5, only they were taken into consideration, and some of the variables they were having a very good correlation with other variables also, so I neglected them. Okay, so for example, uh, this variable was correlated with number 3, so I dropped it here. So only how much is from 28 variables I went to, just see here, 1 2 3 4 5 6 7 8 9 10 11 variables only. So that reduced my input matrix. So this technique was not used in my the previous paper of conjugate gradient. So this technique I also applied in addition to the neural techniques, new neural techniques. I used another pre-processing technique here of dropping some variables. So instead of taking all the variables into consideration, I dropped most of the variables which are having very good correlation with the other variables. So that reduced my input matrix and that increased the speed of the processing. Okay. So you can see here. Here you can see here it was taking some techniques were taking 3 seconds. Okay, and if you see the next paper, it was taking 1.5, 2.25, like that. Of course, it depends on the technique also. It's not only dependent upon the whether how many variables are there at the input, but we were able to achieve good accuracy by reducing the input matrix. That was the advantage. Okay. So principal correlation analysis PCA technique was also used here. Sorry, principal component algorithm was also used here. Along with the correlation technique, which as I have discussed here, I took out the correlation that which variables are also having good correlation with this parameter. So, but only this one was taken. So only the weather variable which are having star in this column, only they were taken for as input variables. Okay. So this is what how we have done the forecasting. Okay. Now
Thank you, sir. If there are any participants' questions, they can be taken up. Forecasting is usually price forecasting, load forecasting, and renewable forecasting. That's why we have given 2 sections, special sessions for this. One by Dr. L.M.Saini and another was by Dr. Anamika Yadav. And then one prominent technique, which is the latest one, that is transformer technique, that was taken up by Dr. G.N. Pillai. And participants may use these machine learning techniques for in their forecasting as well as in their other AI-based applications as well. So if there are any questions, then a session is open for discussion.
Yeah. Any questions, please?
If there are no questions, I think we can wind up because at 12 o'clock we have to start the feedback session. So if the participants permit, should we wind up?
Okay, participants, thank you for allowing me, and I would also like to thank the faculties at the Thapar Institute for allowing me to share my research experiences in the area with them, and I have tried to motivate them. So let us hope the participants will take into consideration these things when they go for their own research. So I wish all the best to the participants.
Okay, sir. Thank you, sir. Thank you, sir, for being here. Now I would like to wind up. Thank you, sir.
Okay. Thank you, everybody.